Welcome everyone. So we waited a little bit for everyone to come. If people join later, it's totally fine. I'm gonna start by sharing my screen. As you see, we also have an authorization poll just to see like a temperature check of everybody on how familiar they are with inline authorization. So if you see the poll, please feel free to answer it. We are gonna look at the answers in like 2-3. Let me start my screen share. So as you all know, we are going to talk about fine-grained authorization in Python. And I'm here with Greg, my teammate. We're going to be the facilitators of today's webinar. And we're going to learn how to separate application logic from authorization, logic with dynamic and context-aware policies. We are also going to discuss like some of the limitations of roles and hard-coded permissions and learn like how to implement some of the policies for you to maintain your code better and scale and whatnot. So let's see what people answered. We have our polls. Steffi, if you want to end the poll and show everybody the results, we can go over them as well. Awesome. So wow, that's a very good breakdown. So some people said yes everywhere. We check permissions directly in our code. Some people said somewhat. They mix inline checks with centralized authorization systems. Some people said no, it's centralized. And some people said not sure. I don't know what inline authorization is. For those who don't know, inline authorization means checking permissions directly in application logic, like if user is an admin, but this lives inside of a function. So every time you have to check permissions, you have to basically update your code and redeploy and rerun it. Because who would want their application logic directly enforcing authorization rules? No one. I'm gonna stop sharing the poll. Cool. This is our agenda for the day. We will start with an introduction and then discuss how RBAC and hard-coded permissions break down with modern app requirements, and then provide some industry examples, explore what does work in real life, and explain how this all ties together. Culminating in a demo. Greg's going to do the demo for us. And there you will learn how to separate concerns between application logic and authorization logic, as well as the best practices for implementing fine-grained authorization models. We will finish with a Q&A, but feel free to ask any questions in the chat. We have a bunch of teammates here that will be monitoring it, so they will give you links and updates and whatnot. I wanted to start with a visual video of like a visual reminder of why hard-coded permissions struggle to meet a modern app requirements before we dive deep into the rest of the webinar. Because we all been there, everybody starts off by rolling their own authorization. It's simple enough at first if you only have one person, one capability, but then you add new endpoints and you add new capabilities, another service, then 3 or 4 more services, an external vendor, and then it just keeps growing. Particularly smaller teams or those in early stages still hard code roles and permissions as a quick and straightforward solution. However, as applications grow in complexity, teams often encounter significant pain points with this approach. And RBAC falls short in modern applications by handling only predefined roles and permissions, and this makes it insufficient for dynamic and fine-grained access control. And some of those examples would be like hierarchical relationships, contextual decisions, and flexible authorization models. And let's just dive deep down into what this results in. So it is rigid. Hard coding permissions ties the logic directly into the code base. This makes it difficult to adapt to the changes in business requirements, such as introducing new roles or permissions without deploying new code. So there's some inflexibility when requirements evolve. We wanted to give a code example here. What happens if you need to add a new warehouse permission or a new permission for all of these roles or a new role? As you can see, it just gets longer and longer. It's hard to scale. As the number of roles and permissions and resources increase, maintaining a hard-coded system becomes unmanageable. Adding new features or resources often requires duplicating code, which increases technical debt. This is especially true in large applications. If your authorization code is tightly coupled to your app code, then you can scale one without scaling both of them. Finally, it's hard to test and debug. When your application code and authorization code are combined in the same functions, it's hard to test one in isolation from the other one. It's also easy to lose track of which code is just there for authorization and which is the work that the function is supposed to be doing. If a test fails, is it because of the authorization code or the application code? That's really hard to know. Now it's time to talk about some industry-specific examples. Let's imagine a totally hypothetical large e-commerce platform with thousands of products, categories, and user roles as example. They may be facing issues when managing permissions due to their hard-coded roles. And hard-coding roles means adding a new product category here or changing access rules required, like altering the source code and redeploying. As we've seen, this approach doesn't scale well as the number of roles, permissions, and users grow. And here you can see all these categories that a company like this may have. As the platform scales, the code base becomes cluttered with if-else statements for permission checks and increases the complexity of the application. This makes the system prone to errors, difficult to maintain, and challenging to debug. And this is from the actual API documentation of the company. Even if you do have a good way to manage roles, roles are just not enough for a modern application. Here's another industry-specific example. This time it's in healthcare space. They have thousands of clients, clinicians, insurance providers, and other user roles. They hard-code roles to control access to patient records. In this case, maybe there's a requirement that a clinician should only see information for clients that have visited them, unless a client's primary clinician shares their information specifically. How would you even implement that? Or a new regulatory requirement could demand different access rules for different groups of clinicians based on their certifications, on roles, or like where they live. Changing these rules manually in the code base can lead to inconsistent behavior and bugs, especially when updates aren't propagated correctly. And testing becomes equally cumbersome because each change requires testing across multiple parts of the application, and debugging becomes complex as well because developers have to trace layers of logic to understand why certain permissions are not functioning as expected. Okay, so now we spend a lot of time talking about what doesn't work, but what does? So these are some of the patterns that do meet the requirements of modern application: dynamic, relationship-based, and attribute-based controls. These often require a mix of authorization patterns, like to balance security, flexibility, and maintainability. And the three key patterns that we will explain in the next slides will explain relations, attributes, and environmental conditions. Here's a relationship example. It's a dad and a kid bear. Relations define how users and resources are connected, like a user being an admin of a project or a member of a team, so that permissions can be granted based on these relationships rather than just fixed roles. An example of this would be a project owner can edit tasks, or an admin can delete a repository. So in authorization terms, RBAC, relationship-based access control, grants access based on relationships between users and resources. Attributes are details about users and resources and the environment as a whole. So this could be a user's department or a document sensitivity level, and it will help determine whether access should be granted. An example of this would be, is a repository public, or is someone specifically banned from accessing this information? So in authorization terms, ABAC, which is attribute-based access control, uses user, resource, and environmental attributes for fine-grained control. And environmental conditions are basically a type of an attribute. So they're context-based factors like time of the day, location, device type, or network security, and these influence whether access should be granted. They're basically like related to the current runtime environment that you have to account for. An example of this would be only allowing access during business hours to EU-based members. So how it all ties together. Here's an example code. You can add authorization to your Python applications with also Cloud. See their admin and member roles, and there's different permissions of the things that you can do, like read or manage. Then you use the also.tell function to send authorization data from your application to also cloud. With the policy and data in place, you implement enforcement by calling also authorize to confirm that the given user has permission to perform the requested action. I have a question to the audience here. Did any of you have to refactor inline authorization logic out of your application code? And if so, how did that go? And Steffi, I'm not seeing the chat, so if someone says something, feel free to say it out loud. Or Greg, you as well.
We have a not yet.
Yes.
How about database logic? If anyone has any examples of that. Please don't all answer at once. Cool. I know it's a little like shy to say something out loud, but I'm just going to continue. If and when your existing logic becomes unmanageable as it's implemented, you will need to refactor the authorization logic out of the application code. This will make it maintainable without affecting the core functionality. And I have a case study right after this because we have many customers and clients that had to do exactly that. So let's give an example. This is a hypothetical situation. We had a company and their authorization logic was spread across various parts of the code base, such as decorators, fields, methods, and serializers. This setup made it difficult to understand the authorization policy for any given resource and even harder to modify it. For example, if they were using Django REST framework with permission classes scattered throughout the code base, they could create a isAuthorize permission class to replace all of the separate permission classes currently in use. But also, you can change the policy without changing the application code. This means the authorization decisions can change. So the power of AUSO's approach lies not in just writing the rules, but also in maintaining and evolving them. As your application grows, you will need to add new types of resources. You will need to support new sharing patterns. You will need to handle edge cases and special permissions. And you will also have to maintain consistency across your application. But also, these changes are localized to your authorization policy and not scattered throughout your application code. This separation of concerns makes your code more maintainable and easier to reason about. And we're going to show a demo on this as well. Like, let's see how this looks in an application and how difficult that is to write as pure Python and how it also simplifies it.
All right, great. So I will jump in from here. Just let me do a little bit of window rearrangement before I get going. Great. So we're going to take a look at a demo application that sort of illustrates a lot of what Hazal has been talking about over the last few minutes. So the application is a sort of hypothetical order management app that has basic functionality. There's a demo scenario that has two organizations who are using this app, and each organization has a few roles in it. The app is used to do one of three different actions on an order. You can either fulfill an order if you work in the warehouse, you can cancel an order, or you can delete an order. And these actions are tied to roles in the application. So there's an admin role that is able to do all of the order actions. There's a sales role that can cancel an existing order, but only if it's an order that they created. And then there's a warehouse role that is able to fulfill the orders. And those correspond to the different buttons. So the fulfillment action is the little green check mark. The cancel action is the little red X. And then the deletion is the trash can. So the app will allow you to select an organization or role combination, and then you can use the app in the context that you select. So that's what you'll be seeing as I'm kind of going through the application. So why don't I'll take over the screen from here and start sharing my screen. I would say about 80% of the time that I do this, I select the wrong screen. So, just a little warning.
Today is 20%.
It's 20% Thursday. Is that where we are? Are we seeing the application?
Yes.
Victory. Okay. So this is the app that we were just kind of walking through. As you can see, we've got the Acme admin role selected here. Yes, the two organizations are Acme and Zombo, so that they can be very easily distinguished by one another from their first letters. We have 4 orders here. 2 of them created by sales reps at Acme, and 2 of them have been created by sales reps at Zombo. So as an admin, you can see I can do anything I want. I can, except I have bad aim. You can fulfill an order. I can cancel this order here. I can delete the order. If I choose the Zombo admin, I can do the same things with Zombo orders. So we can reset this to get back to the state. Initially, a lot of times when you see this, let's take a look at some of the code that sort of powers this, right? So let's see how my flipping is going. Great. So this is sort of the sort of thing that we see a lot in initial code bases, right? So we've got a couple of different functions in our Python code for deleting an order, for fulfilling an order, for canceling an order. And if you take a look at the code here, by the way, is this legible at all? It looks great on my screen, but I don't know how it's translating to. Great.
It looks good on mine as well.
Okay. If you take a look at the code in the delete order function for one example here, you can see that we're doing a lot of stuff that's actually not technically anything to do with deleting an order. It's checking the authorization logic to make sure that the person who is making this request is actually allowed to delete the order, right? So first we're getting the user's role and we're checking the permissions. We make sure that the role has the delete order permission, and if they don't, then we throw an error. Those permissions, again, we see this sort of thing somewhat commonly in early stages in applications. In this app, the permissions are just sort of hard-coded in a file. It looks very much like the one that Hazal was showing earlier, right? So sometimes you'll see this. If we just have a simple role-based authorization model, it's enough to just take a little file, define the different roles in the organization. So here we have warehouse and sales and admin. Then you can define the permissions that are associated with those different roles. Warehouse can view and fulfill. Sales can view, create, and cancel. Admin can view, cancel, delete, or fulfill. And this sort of illustrates, the kinds of things we can run into. Maybe someday we want a different permission. Maybe there's a return order permission that only the admins can do, or a salesperson can initiate. And then we have to add another return underscore order to this little enumeration and add it to the right roles here and redeploy our application, right? Or maybe we create another role entirely, and then I need to add another block to this and assign the correct permissions. And if I need to add a new permission there, like this is manageable with a couple of roles and a couple of permissions, but over time, that gets unwieldy, both in terms of just reading this file as it gets longer and longer, but then trying to remember like which permissions go to which roles and editing them in all the same places. But for now, this works, and we can do role-based access control with a pretty simple mapping in Python. But there is another wrinkle here, which is, if you notice, I was very specifically not trying to do anything in the application that crossed organizations, right? So when I was in the Acme context, I was only messing with Acme orders, and when I was in the Zombo context, I was only adjusting Zombo orders. But really, we don't want people to be able to edit orders outside of their organization, right? And right now, as the Acme admin, if I wanted to, the way this is written, actually I can't go in because apparently I am doing this better than I thought. That would delete. Let's go ahead and just make sure that this is saved, and we'll restart this. Yay, live demos. Acme admin. Okay, well, we're not going to debug this right now, but I guess I'm doing this more thoroughly than I thought I had been. Actually, I think I know why this is happening. But In the case of an application like this, right, you do want to make sure that the functionality isn't bleeding across the organization domain. And so here, you actually can't encode that in roles, right? Like the role-based permissions, if I'm an admin, I can view and I can create, I can cancel and I can delete. If I'm sales, I can do whatever a sales can do. There's no notion in RBAC about like membership in an organization or that sort of thing. That is actually a relationship-based consideration. And so in order to enforce that, you actually have to have logic that can't really be easily captured in role-based access control. And that here is what we're doing here. We're checking the organization that the user belongs to and the organization that the order is associated with, and ensuring that those match before the code actually, or before the action is authorized. So we've got what, like a 25-line function here. 20-ish of those lines are dedicated to actually verifying that the person is allowed to do the thing that they're trying to do. And then we've got 3 lines that actually do the work of deleting an order, right? So this is the sort of thing that we see a lot with inline authorization code. We've sort of mixed the concerns here. We've got a function whose purpose is to delete an order, but actually the majority of the logic inside that function is just tangential to the actual act of deleting, and it's encoding the authorization. If we go down and look at some of the other functions here, there's the fulfill order function, and you'll see it's very similar to the delete order function. In fact, much of the beginning is identical, with the exception of the fact that we're looking for a different permission, fulfilling the order rather than deleting the order. And then we come down here, and after we've verified that they have the fulfill order permission, and we verified that they can, or that the order belongs to the correct org, then we have, again, 2 lines that actually change the status of the order and return the updated order to them. So this is another thing I think that we see a lot in when we're working with inline authorization code, is that as we sort of add these things sort of function by function, a lot of the authorization logic ends up being duplicated across multiple functions, right? There's not really any difference between the check in the delete order function for the permission and the check in the fulfill order function for the permission, except for what the specific permission is that we're looking for. But aside from that, we're getting the user's role, we're associating that with a permission, and then we're validating that the permission is the one that we expect. This tends to happen with inline authorization. We just sort of see this proliferation of very similar checks that start getting copied and pasted from one function to another because it's quick and easy to do. And again, 3 or 4 functions, not a big deal. 20, 30, 40 functions, it starts to get pretty unwieldy and difficult to manage this. Then as we come down to the cancel order function, I won't belabor much of the beginning of it. It's, again, very similar to the previous 2, but now we have this extra wrinkle in the cancel order function. And again, this isn't something that we can capture in a role. We had said earlier that we only want a salesperson to be able to cancel their own orders. And we'll go back and take a look at this. And actually, just for the sake of being thorough, right? We wanted to make sure, for instance, that sales folks are not able to fulfill orders, but if I switch over to a warehouse person, they can fulfill, and you can it just shows the status changing to fulfilled. In the sales scenario, we want to make sure that Acme sales rep 1 can only cancel their own orders, and we've got that in place here, right? So this person can cancel the order, cannot cancel the order that was sold by sales 2. I have to switch over to sales 2, and then sales 2 can cancel the order. And we are checking to make sure that the roles are correct, the organizations are correct. We had to go again outside of our role-based access control model in order to implement that by adding a check here that makes sure that if the user has the sales role, and then we have to make sure that the order was sold by that same user. And if those don't match, then we throw an error, right? And this only matters for sales, because remember, we said earlier that admins can do anything, right? So there's a little extra wrinkle. So if I pick an admin, admins can go and happily cancel any orders that belong to their organization all day long. So this is another thing, you sort of start getting all these edge cases that creep in. Like, oh, right, we have to handle this little bit of logic. Oh, right, we have to handle that little bit of logic. And so you get these little extra if statements and extra little bits of logic, authorization logic that kind of creep into the functions. But once again, now we're push in 40 lines for this function, and the actual work of the function is the last 2 lines, and everything else here is authorization logic. So that's sort of an illustration of what can happen when you have this sort of hard-coded inline authorization logic in your application. If you want to start sort of wrangling this and separating those concerns, so the first thing that you can do is just pull that authorization logic out of the functions inline, out inline in the functions in your Python code, and just move them off into a separate library. And that's what you'll see in this app abstracted.py. So this is the same, functionally the same. We'll switch over to using that as our backend app abstracted, just to show that the behavior doesn't change. But what you do see is, if we just quickly take a look at the delete order function, for instance, rather than saying directly if the delete order permission isn't in our list of permissions, we're now calling this has permission function, which we're importing from an authorization module that we've created. So if we take a quick look at this authorization model, as I scroll all over the place, here's our authorization module. We've just taken the logic that was inlined in the hard-coded version of this, checking for the delete order permission, the fulfill order permission, checking for the organization, and we've just shifted it off into another location, right? So, which I scrolled past. So we have a has permission function that we can now pass a permission and check to make sure that the permission that we have sent in is in the list of permissions associated with the role for the user that we're checking. We can pass in an order and a user to this has same org function, and it just checks to see if they're in the same org. Like, these are pretty simple bits of logic, but the point is that you can take this authorization specific logic and just pull it into a different location, into a different module in your code base, and you can start the process of separating the concerns without actually even having to leave the Python world, right? Similarly for this user is owner if in sales. So functionally, we're doing all the same things. We've just sort of restructured the code a little bit so that the authorization logic is in one place, the application logic is in another place. So if we take a quick diff of those functions, then I guess I hadn't. That was not as staged up as I thought I was. Sorry. Cool. So you can see the changes between the two, right? So everything that's in red has been deleted when moving from the hard-coded version to the abstracted version. Anything in green has been added. And if we just take a look at this, most of what has been removed are just the sort of inline checks of the role and the permissions. And rather than doing this sort of direct, for instance, create order in permissions, we are calling has permission to make sure that they have that order. It's similarly for delete, similarly for fulfill. And then same thing, now we don't have to actually pull the user org and the orders org out in the functions directly. Instead, we just pass the user and the order into this has same org function, and it does the work of verifying that the two organizations match. So we've simplified this somewhat. You can see there's a little bit more red than there is green. The functions are getting a little smaller, but there is still some authorization work happening here, right? We're still actually checking whether the user has the permission by calling this function and returning the error inline in the function. So we've streamlined things a little bit, but we are still sort of making the authorization checks in the function, even though we're not implementing the authorization logic in the functions. So we've taken a step along the way. And if we go back over to the application, remember I did start serving app abstracted as the backend. I can refresh this and we'll switch over to the sales person and they can cancel. We'll reset the orders as well. And they can cancel an order, can't cancel the other order, can't cross the orgs. So like functionally, we've preserved the functionality that we needed, but we've sort of reorganized the code. And now another benefit that we've gained from this, rather than having that hard-coded permission check repeated from function to function to function, we've consolidated it right into a single parameterized function. So we only need to implement the logic that says find the role, find the permission, and check that the permission exists once in this one place. And then we pass in the user and the permission that we're interested in, and that check happens here. So now we've consolidated the logic. We're only implementing this permission check in one place. If for some reason we want to change the way this is implemented, we don't have to go and change it in 3 or 4 different functions directly. We can just change the behavior of this function, right? And it'll be reflected everywhere. So some benefits already. The next thing, though, that we can do is, now that we've removed the authorization logic from these functions, we can also pull that evaluation of the authorization out by switching from doing the authorization checks in line to using decorators in Python. And so, for Python specifically, decorators just give us a way to sort of wrap a function in another function that extends the wrapped function's behavior. And so in our case, what we're interested in doing is making sure that anytime we need to call a certain bit of authorization logic for one of our functions, we just wrap that function in a decorator that enforces the logic to be applied. So what that looks like is in this function app decorated. I should mention this is all in a GitHub repository that we're going to make public and distribute after the webinar. So if you'd like to kick around any of this code, you're more than welcome to do so. We'll send that out afterwards. So if we look at the decorated version of this, you'll see that now our delete order function has actually become much smaller. And this evaluation now and the logic has been moved into what's called authz.py, where we've added some things. So it's the same initial permission checks, and then we've just added a couple of wrapper functions that implement our decorators for us. So we include in our require permission decorator the has permission function and wrap. We can wrap a other function in this logic. So we've sort of increased the amount of code that's in our authorization library in the name of decreasing the amount of code that's in the actual application code. So the really nice thing about this on the Python side is that if we now do a diff of what we've been of the step that we just took from the abstracted version to the decorated version, typing and talking at the same time is not one of my strengths. So pardon me for a second. Now we're seeing a whole lot more red, right? So all of this inline logic that was just there for the sake of doing authorization, like implementing authorization logic or evaluating authorization logic, is now gone. And instead, we import these decorators from outside, and before any function that we want to apply some authorization logic to, we just add the decorator that includes that logic, right? So we require a permission. We require either the create or delete. We require the same org, and now the only logic that remains inside these functions is the logic that's required for the actual operation that the function is supposed to be doing, right? So if we come back over to the window here, now we've moved to a state where our application code is just the application code. It's very clear what this delete order function is doing. It's pulling some orders, it's deleting the one that we asked for, and then it's saving the orders, right? The fulfillment one pulls the order we asked for, updates its status, throws a big dialog in front of it, and then returns the updated order. So it's much easier now to read what's going on inside these functions. In fact, it's easier to pick out things like I didn't actually need to pull the whole list of orders for my cancel order function because that orders variable is never referenced. I've been missing that for 2 days as I've been going through this demo because of all the other code that's wound up in these things. So it becomes much easier to maintain this code when you start removing all the authorization logic. It also becomes more straightforward to start reasoning about the authorization logic itself, right? Like there's a little extra syntax now around these decorators, but really the meat of what's going on here is in these functions here that have abstracted the logic, and we can see that we're pulling a role, finding the permission that role has, and then returning true or false if that permission exists in the permission. So we've made it much easier to reason about the two things we've made our code more legible. And an interesting thing that kind of starts to happen if you do this in this way is the function signatures and the decorators kind of start to read like an authorization policy, right? Like we can look at this here for fulfilling orders. I don't know why I picked the one with all the R's and L's, but there you go. And we can see that in order to fulfill an order, you have to have the fulfill order permission, and you have to be in the same org, right? So we can actually kind of read through the functions here and learn what our authorization policy is by going through and doing this. So this is pretty nice. We've got legible application code. We've got pretty explicit authorization statements that are governing each of these functions. Now the last step that we can take is we can actually just remove all of that authorization logic entirely from the Python code base and implement it in OSO in Polar, and then we don't even end up with all of this extra decorator work going on. And so what that looks like, we will go ahead and stop. Did I ever? Oh, okay. Just to make sure that I'm not doing the man behind the curtain thing. We're serving app decorated.py. If I refresh this, right, we'll go with the Zombo folks now. Zombo sales 2 can't do anything in the Acme organization. Can't cancel sales 1. Can cancel sales 2. A warehouse person can fulfill. Can't delete, right? So the logic, the functionality is still the same. We just kind of keep shifting or switching out the back end. So our final step, we implement this logic in an authorization policy in OSO. And so what OSO's policy language is called Polar. And this is how that logic that we had encoded here in the authorization module looks in Polar, right? So we have a test for permissions. We have this test for organization membership. We have this test to make sure that sales rep is the owner of an order before they cancel it. In Polar, we'll just do a very light introduction to Polar because this is more of a Python focused thing. We have 2 primary entities that you'll see us working with a lot. There's actors, which are the entity that is attempting to perform some action. And then we have resources, which are the entities that they're attempting to perform that action on, right? So a user can belong to and do some things in an organization, or they can attempt to do some things and have some permissions on an order in this model. We spell out the roles and the permissions that exist at an organization level and an order level. For this, we've been focusing primarily on the order. So you'll see that it was actually exclusively on the order. You'll see that the permissions are the same that we were talking about: view, order, fulfill, cancel, delete. And we've defined the relations that exist for an order. So you can have a relationship between an order and a user that defines which user sold that order, which comes into play for the cancellation logic. And then you can have a relation between an order and an organization, which comes into play for that logic that says I can only operate on orders that belong to the same organization that I do. And then we can define how those roles and relationships confer various permissions, right? So admins get any permission as long as the org membership is the same. Members of organizations can view any order. If you're the person who sold, then you also get the cancel order permission. And if you have the warehouse role in the organization, you can fulfill the order, right? So we've basically encoded the same logic that we were talking about before, just here in Polar syntax in a very authorization specific way. And then I have running locally just the OSO dev server. We can send out a link to the documentation for that, which is just a local implementation of OSO Cloud that is perfect for things like webinar demos and local development and that sort of thing that you can just run on your laptop. And so what we've done now is loaded this policy into the little local standalone OSO dev server. And now the authorization we've abstracted into this authz.py. And what you'll see here is the whole beginning of this function, of this module, is strictly instantiating a client for OSO Cloud and loading the policy into that client. And we're now down to a single authorization operation and a single decorator. And all it does is call oso.authorize with the user and the order and the action that we're trying to do. So now we don't even actually need to know inside our Python code which rules apply to which function that we're trying to do. We've given all that to oso, and all we need to do is ask oso, this user is trying to fulfill this order. Tell me whether or not they can. So that gets reflected if we look at the diffs again. By just seeing we've just basically changed the decorators, right? So instead of this direct require permission, you'll see every decorator now is just authorize order action, authorize order action, authorize order action, authorize order action, right? We're just always saying, is this action authorized against this order for this user? And we don't have to even know, oh, right, to delete, they have to have the delete permission, they have to be in the same org. To fulfill or to cancel, they need the permission, they need to be in the org, and if they're a salesperson, we don't need to worry about any of that in our code. Oso handles that. So now we've even further condensed the application logic. We know that this is an authorized action, and now we see that the only functionality that's actually in our application code is the work of doing whatever that operation is in the application. And the only authorization logic we need to worry about is sending an authorized call to Oso Cloud. And once again, if I go back, let me just double check and make sure that I did actually, nope, didn't. Start the Oso backend. Now I can go back to my application and we will see, he said optimistically, that all the functionality is preserved. Sales 1 can cancel sales 1, cannot cancel sales 2. This text has changed a little bit, so it is different backend code, I promise. And they're just denied across organizations and all of that. So now we've got our application logic, just application logic. Our authorization logic has been entirely abstracted from the authorization code, but it's still code. We can still keep it associated with our code base. And if we needed to extend these permissions and this logic by adding new rules or different attributes, we can do all of that right here in our polar policy, update the logic back at Oso Cloud, and our oso.authorize call remains the same and will return properly. So now we actually can update this policy and update Oso Cloud, and the behavior of the application can change without actually having to redeploy the rest of the application code, which is also a nice sort of decoupling that you get from this. So that's a little walkthrough. Hopefully that has kind of illustrated both how things can start to get pretty thorny if you're writing the authorization code in line, how how role-based access control starts to break down, and how we can sort of alleviate that situation in a nice kind of measured way by abstracting that authorization logic and then re-implementing it in Oso Cloud.
I have one final slide about what to remember from the webinar if you don't remember anything else. So we basically discussed why hard-coded permissions break down with modern app requirements. There were examples about why it's rigid, why it's hard to scale. And then we gave some best practices for implementing fine-grained authorization models beyond just roles, and these included relationships and attributes, and why it's important to separate concerns between application logic and authorization. And this one was mainly talked about in the demo. So if you take away nothing else from this webinar, then please remember these key points. And I guess now is a good time to take all of our questions. Any questions, you can unmute yourself or ask it or just write in the chat. I sent the also dev server documentation in the chat. Greg, if we make the repository public, I can also share the demo as well if you want to go through it in your own time.
Yep. Be a little post webinar tidying up, but let me And we have emails for everyone, right? So we can send that out. We stun people to silence. It's my soothing voice sent everyone to sleep.
Someone said thank you in the chat. It's not a question, but it's a compliment. Another thank you. Cool. Well, thank you all for joining us as well. We will be following up with all the links and share the recording after the webinar as well. And we are excited to see you in the next one.
Thanks, everyone. Take care.